Hello guys, welcome to another episode of Synapsewerx Agentic AI. In this episode, we are going to talk about how is that we can blend generative AI with traditional AI. But before I do that, let me just talk about LLMs. One thing that I'm observing in the industry right now is that we are giving too much hope to LLMs. And don't get me wrong, LLMs are fantastic. They can do things that have never been possible before. But we are seeing LLM as a hammer, and every single problem we see out there becomes a nail, and we just want to hammer it with LLMs. And that is not always the best alternative, especially when the problem is something that has been solved by traditional AI for decades. So let's talk about how is that we can blend generative AI with traditional AI. First of all, let me talk about when is the right use of an LLM. One thing that LLMs are very good at is to bridge communication between humans and systems or data. This is very simple, very human, natural, where a human has an idea, they just simply need to send that idea, the LLM is going to process that, and then it's going to return a response. Very simple, right? The LLM, it will feel like it is reasoning, it will feel like it is intelligent, and it is going to know exactly how to answer the response. Behind the scenes, it's just really mathematics, but ultimately, if the question has something to do with the data that was used to train the LLM, well, most likely the response is going to be good. And most of us are using LLMs today, and most of the recent LLMs are fantastic, right? It just feels like they reason. The other thing that LLMs are very good at is at understanding when they have satisfied the user input. When that is not the case, well, in many cases, they can start hallucinating, but you can also tell them, in this particular case, don't use the data that was used to train you, use something else. And this is where we can start talking about blending traditional AI with generative AI. So let's talk about this example. This is a local real estate agency. Let's imagine, and in this case, we are just providing a mechanism for end users to communicate with an app, whether it's a web, a chatbot, or whatever it is. These users are going to be talking about things that are real estate related. And let's assume that this person wants to know about my house price. What is the valuation of my house? Imagine what would happen if that question is sent to this LLM. Most likely, the response is not going to be very precise. Most likely, the LLM is going to use the internal data that was used to train it, or in some cases, it might want to go and fetch something from the internet in order to come up with the best possible answer for this user. But that is not going to be very precise. Now imagine that we are talking about something that it is life-threatening, and the number that is returned has to be super accurate. Well, in these cases, an LLM is not the best choice. It is still the best choice to communicate with a human, to reach that communication that we mentioned in the past. But now we need to delegate that responsibility to something else. And like what I just said, traditional AI, traditional data science has been able to solve these problems for a long time. And we are talking about, traditional data science techniques around problem exploration, data engineering, model engineering, deployments of models. And then ultimately what happens is that then there are going to be a lot of machine learning models, small ones. We are not talking about large language models, but we are talking very specialized, cost-effective, highly accurate models that can be used in order to get the right level of outputs that we want. In this case, let's talk about prediction. Let's say that given the house land size, we are going to use internal data from this real estate agency in order to train the model that ultimately is going to provide a very accurate house price prediction. Okay? So that model is going to be running. We are going to front end this model with a microservice that is simply just exposing an API. And the thing that we are going to do now, instead of delegating that responsibility to the LLM, what we are going to do is give this LLM a toolbox, where inside this toolbox there is going to be a price prediction tool that ultimately knows how to communicate with this microservice that ultimately is going to be using this traditional AI machine learning model in order to return a number that then is going to be used by the LLM in order to respond in natural English to the user. Let's see this in action. Okay, but first, let me just give you a glimpse of what happens inside this traditional AI world. And for this, I'm just talking about traditional data science. For this, I'm going to be using this Jupyter notebook that I created in order to crunch data, some data, in order to train my machine learning model that is going to provide highly accurate house price predictions. So let's start building this one step at a time. So the first thing that I'm going to do is to run this. These are touch points. These are relationships between house sizes with the price that basically they had. And again, this could be hundreds of records, could be thousands of records, millions of records, doesn't matter. The more accurate this information, the better, okay? The next step is that we are going to split this across 2 dimensions, X and Y. And we are going to use 80% of this data in order to train my model, and 20% is going to be used for testing. So let's run this. We know in this case that a linear regression is probably the best possible way in order to create this the base of the model. And then we are going to provide those X and Y dimensions. Let's do it. Okay, so now my model is created. So let's actually put it to test. Let's start doing some predictions. Let's first of all, let's identify what is the mean absolute error. In this case, we are seeing that the error was 10.75%. What this basically means is that my model, the model that I just trained with this data, is around 90% accurate. Well, let's actually test it and let's see what happens. Before that, let's visualize what we just did. So in this case, each of these blue dots correspond to one of those plots, like X and Y relationship, like house size and the corresponding price. And then the red line is the linear equation that we created that ultimately it was the result of a trained model using a linear regression in order to identify the mathematics that ultimately can receive future data points in order to derive a very accurate prediction. Let's actually see that. Let's start making some new predictions. So now what I'm going to be doing is sending new data. This is data that was not part of the original data. So when I do this, it is going to basically tell me that, for a house of this size, 2,500 square meters, is going to be this price. And then so on for this, so on for this, and so on for this. If we want to visualize this, then basically what we are seeing is that this is what we had done before, the linear regression. All the blue dots are the trained data. And now these 4 green dots are the new predictions. So now that we have this model, and again, this model can be downloaded, it can be taken to the best cloud provider of choice, and then it can be wrapped with an API. And why we want to do that? Because, well, the next step is to use this model in order to receive an input, in this case, going to be the house size. And with this input, we are going to provide a very accurate prediction of the price. And for that, we just need to wrap it as an API, simple stuff. We can do it using whatever framework. We can containerize it, run on Kubernetes, whatever you want to do. Ultimately, we are just going to be using this model. This is a small model. We are going to wrap it as a microservice. We are going to put an API. And then in the next step, we are going to use it as part of a toolbox. Let's do it. Okay, time to put everything together. So for this, we are going to create a very simple agentic workflow that is ultimately going to be using the blend between traditional AI and generative AI in order to communicate with a human, but using the very accurate prediction that we trained before. So for this, I'm going to be using Langflow. Langflow is a framework that runs on top of LangChain by DataStax, and it is a great choice in order to create agentic workflows. So the first thing that I'm going to be doing here, as you can see, there's an input. There is going to be a chat just to interact, just to test that very, very easily. There's going to be an output. There's going to be an agent in the middle that is going to be using, as you can probably see here, OpenAI GPT-4o Mini. And then as part of the tools, then it is going to be using this tool that, again, I just use in order to communicate very easily with a microservice that is ultimately using the machine learning model that we just trained before. Let's just have a quick look about the agent instructions. So this is like, well, you are about real estate assistants. If the question is related to house price prediction, only use the associated tool. And if that happens, then you have to retrieve first name, last name, and the house land size in square meters. Then, in order to make that prediction, you have to follow these 2 steps. Step number 1, again, simple stuff. I know where my API is. So in this case, I'm just going to put it, URL. We can use more sophisticated ways in order to hook into other types of APIs. But in this case, I just want to prove that I'm going to be using my underlying machine learning model. And then it's going to be the payload that is going to be sent to this machine learning model. And again, it is going to not be smart enough in order to replace whatever was the input from the house land size into this dictionary or this JSON payload. And again, just going to be sent that. Step number 2, just read from the response that you get back in order to provide that house price prediction. Okay, let's take this and let's prove it. Let's just create a new session. Let's say, hi. How can I assist you today? Can you tell me about the weather? Well, they should say no, because I'm here to help you with house price predictions and maybe some real estate information. Okay. Yes, please. Can you help me with the valuation of my property? As you can see, again, I don't have to even think about what I'm sending. It will understand the sentiment of what I want to achieve. Like, yes, I can. I know what you want. And again, it went into those instructions that I just prepared before. And as I dictated, then give me that information. So let's play a little bit with this. Let's say my name is Carlos, only Carlos. It should say, okay, Carlos, good. But now what about your last name and the land size? Oh, it's like, oh, sorry. My surname is Iturria, and my house land size is, let's say, 5,000 square meters. Let's say 50,000. Let's just dream big. My surname Iturria, house land. Okay, let's go with this. And then it should know at this point in time. See the tool that I instructed to use when these type of problems occur, that's what it was used. And it said like, well, the predicted price for your property, Carlos Iturria, with a land of size of 50,000 square meters, approximately $7,575,000. If you have any more questions or need further assistance, feel free to ask. So let's see what happens here. So as I said, basically, this is the instructions that I created. It did it all automatically. I didn't have to worry about writing this Python code. And it basically got that response from my underlying microservice that was hooked to this machine learning model. And yes, this is the information that was retrieved. So as you can see here, we are blending across generative AI. I don't have to think about what I'm sending. I'm not sending JSON payloads. I'm literally just communicating with English. And what's happening is that the LLM is going to be smart enough to understand what I want. And given the instructions that I'm given, it is going to use certain tools in order to satisfy my requirements. In this case, when the requirement is very specific around house price prediction, it will know that it has to use a specific tool. And it happens that that tool is using the small machine learning model that we just trained before, that is going to provide very accurate predictions of house prices based on the land size. I hope with this video you found it useful and know exactly when to use an LLM, when to use traditional AI model, and how to blend them together. Thank you.